Hello, so question 2. This is all about this graph here, right? This is making use of a maze that was turned to a graph. So 1 can go to 2, where can 2 go? 2 can go to 3, 2 can go to 4, and 4 can go to 5. And they've transposed this into a graph here. Okay, so we've got a procedure, and they want us to do a trace table for this. So these can be a bit long, but they're not bad if you just follow through exactly and don't skip any steps and don't feel like, oh, I know what to do, so I'm just going to whiz through and blah, blah, blah. And that means you might miss something. So it's really important that we just work our way through slowly. Now, what I would recommend, if I scroll down, even though they've told us to start here, I'm just going to talk through so we know how this works. And we're just going to go through everything. V is starting as 1, and NV is going to be 5. Okay, so we plug the N, NV is going to be 5. NV is always 5. Everything is set to not discovered and not explored, and we're going to go through. First thing we do, we've set discovered 1 to true. Oh, look, there it is. And then, does 1 equal 5? Nope, so we're going to continue. Then we go through each neighbor of 1. Well, the first neighbor of 1 is currently 2. All right, so we're now currently at 2. Fantastic. If discovered u equals false, well, have we discovered 2 yet? No, so we're going to do a cool. We're going to cool with u as 2. NV is still 5, it hasn't changed. So v, this has now become 2. And that means we've cooled again, and now we've come to 2. So here we are. Fantastic. Discovered 2 is now true. Oh, look, there it is. Is 2 equals 5? No, it's not. So we can move on. And we're going to go through every neighbor of 2. Okay, what are the neighbors of 2? Well, the neighbors of 2 are 1 and 3. Okay, the first one of 1, first one is 1. Is 1 already discovered? Yes, it is. So we can skip this loop. Sorry, the neighbors are 1, 3, and 4, aren't they? So we did 1, and then we're going to go to 3. And here we are. Is 3 discovered? No. So then we're going to do this call, but plug in u. Currently, the u was 3. NV is still 5. So we've done this 3, and you've been called to a DFS 3. Discovered 3 equals true. There we are. So now we've gone to 3. And does 3 equal 5? No. So we're going to move on. And we're going to go through each neighbor of 3. What are the neighbors of 3? 2. So the first one we're dealing with is 2. If discovered 2 is false, then we do this. But it's not, right? We've already done 2. So that means we skip this. And I've got no more neighbors left. So I have to end this for loop, and we're going to jump to now. We're gonna finish 3. We've done 3, right? So we're going to come back and complete 3. And then what happened after this? Well, who called 2? Well, 2 was called. Well, who called us? Sorry. Well, we were called when 2 called us from before. So we're going to jump back to here. Okay, fantastic. So we're now in the in the 2 call, and this is where we kick in. So we're now going to start doing 4. I'm also going to say that we've jumped back from 3 to 2. Right, here we are. So we've done 4. We're now on 4. Is 4 discovered? No, it isn't. So we can continue. Then we do this call where u equals 4. All right, fantastic. So now we've done this call, and that means we're going to plug in to 4. That's here. And we need to make 4 discovered. Lovely. Is discovered for... Oh, sorry. And then say, if does 4 equal 5? Nope. So we move on. And now we do all the neighbours of 4. What are the neighbours of 4? The neighbours of 4 are 2 and 5. What's the first neighbour? First neighbour is 2. Okay, as you can see, we've got 2 and 5 here. Fantastic. Is 2 discovered? Yes, it is. So we skip this and go to the next neighbour, which is 5. Is 5 discovered? No, it's not. So we do this cool and we go to 5. So, sorry, we went to 4 and now we're going to 5. Okay, fantastic. So we've now gone to 5. We've now gone to 5. That means we're here and we can set 5 to be discovered. Okay, so here we are in this cool. We can set 5 to be discovered. Excellent. For each, is 5 equal 5? Yes, it does. Yes, it does. 5 equals 5. NV is 5. So this is now true. Fantastic. And now I can say for each neighbour of 5, what are the neighbours of 5? Neighbours of 5 are 4. All right, so let's go through the first one. Is 4 discovered? Yes, it already is. So we can skip this, and therefore we're going to. Do you have any more neighbours? No. So we've completely done 5. That means we can do this. Completely explored 5 is true. So here we are. I've got a completely explored, and I can put that there. And now what's going to happen? Well, we've finished. So we're starting to jump back. We're going to jump back. We've ended the procedure and jump back. Where do we get cooled from? Well, when V was 4, we were cooled there. So we've jumped back to when V was 4. Okay. Where are we going from here? Well, it looks like we've run out of neighbours again. Because we were cooled here, and now we've got to end this. So we jump out, and now we're completely exploring 4. So we've jumped back from 5 to 4, and now we finish 4. So completely explored 4 is going to be set to true, and then we end this function. So where do we jump back to? We jump back to where 4 cooled us. Well, 4 was cooled by 2, right? So jumping back to 2. And we're now in the cool where we're at 2 and 5. So here we are. Do I have any neighbours left from 2? No. So I've got to end this for loop now, and therefore we're going to completely explore 2. So we're going to completely explore 2 here. Excellent. And now after this, we've got to end the procedure. There's nothing left to do, so we've got to jump back to where we were. Who called us? But 1 called us. So we're going to go back to 1 here. And now we are at 1. Are there any more neighbours of 1 we need to do? No. So we've got to end this for loop and completely explore 1. Fantastic. And now we've reached the end of this procedure. So we end. And that's it. Because we're going to go back to starting from nothing. So that means we've ended the function.